Hey guys, I am here with you today wanting to go ahead and go over lesson 43. This is Algebra 2. Hold on, sorry. This is Algebra 2. We're going over lesson 43, which is going to involve sine, cosine, and tangent. All right, if I have a triangle, all right, it's a 90-degree triangle, and the angle right in here is 30 degrees. This side length over here is 4 degrees, this side length is 2 degrees, and this side length is 3.464 degrees. All right, I say that I have another triangle. This one's going to be bigger. Oops, that's not the shape that I wanted that to make for me. So I'll throw that away. All right, let's do a bigger triangle here. Okay, still a right triangle. This one's going to have, this side's going to be 120 degrees. This side's 60 degrees. This side is 103.92 degrees. And this angle here is also going to be 30 degrees. And then let's do one more triangle. Okay, also a right triangle. The side here is going to be 240 degrees. This side over here is going to be 120 degrees, and this side down here is 207.85 degrees. All right, I can take these and develop some ratios among the sides of these triangles. If I look first, okay, let's think first here. If I've got this angle down here, this 30-degree angle, the side that is straight across from this is opposite, okay? This side right here we know is the hypotenuse, all right? And this side down here is going to be the adjacent side. The adjacent side makes up one of the two lines that makes up the 30-degree angle. So that 30-degree angle is made up by these two line segments. One of those line segments is the hypotenuse. The other one is what we call the adjacent side. So you have three sides. We know where our hypotenuse is. The hypotenuse is always opposite the 90-degree angle. All right. The side that we consider opposite is across from the angle that we're considering. It doesn't touch. It's not one of the lines involved in making that angle. And then the other line that's involved in making the angle is the adjacent line. So when I look here on this second triangle, over here, this one that's 60 is the opposite. And on this final triangle here, this one all the way across over here that's 120 in length is opposite. Okay, my hypotenuse stays my hypotenuse in all of them. And then the adjacent line is still, this bottom line right here is going to be my one that's adjacent. Okay. Well, I can create a ratio by taking the opposite, the length of the opposite, and I can divide it by the hypotenuse. All right, if I take the opposite is going to be 2, and I divide it by the hypotenuse, which is 4, I'm going to get 0.5, right? Well, over here on this other triangle, I've got 60 divided by 120, which is also 0.5. And over here on this third triangle, I have 120 divided by 240, which is also 0.5. So all of these are going to equal the same thing. They're all going to equal 0.50. Okay? Well, let's look if I take the adjacent side and divide it by the hypotenuse. So this is going to be my adjacent side. I'm going to divide it by the hypotenuse. Okay, my adjacent sides are 3.464 divided by 4. My other one is 103.92 divided by 120. And my final one is 207.85 divided by 240. Well, if you divide those, you're going to find that all three of those problems come out to 0.87. So those are all consistent. All right. And then finally, I can look at one more relationship. I'm going to look at the opposite side I'm going to take it and I'm going to divide it by the adjacent. All right, so if I do that, I have 2 divided by 3.464. I have 60 divided by 103.92, and I have 120 divided by 207.85. Well, if you do the math, you're going to find that all 3 of those fractions divide out to be 0.58. Okay, so what I found here is when I have a 30-degree angle and I divide the opposite by the hypotenuse, I get 0.05. When I have a 30-degree angle and I divide the adjacent side by the hypotenuse, I get 0.87. And when I have a 30-degree angle and I divide the opposite side by the adjacent side, I'm going to get 0.58. Okay, those amounts are going to be consistent regardless of the length of the side. If you take with a 30-degree angle and divide that opposite side by the hypotenuse, you are always going to get this 0.50. Here you're always going to get this 0.87, and here you will always get this 0.58. Okay, what we call these relationships are the sine, the cosine, and the tangent. Okay, so what I can say right here is that the sine of a 30-degree angle equals 0.05. The cosine of a 30-degree angle equals 0.87. And the tangent of a 30-degree angle equals 0.58. And I find the sine, the cosine, and the tangent of those angles by taking and dividing opposite by hypotenuse, adjacent by hypotenuse, or opposite by adjacent. Okay? So this is how we calculate sine, cosine, and tangent. There's some things to kind of help us remember this. We tend to keep them in order of sine, cosine, and tangent. We tend to list them in that order. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over adjacent. What is popular is to think of the little phrase so, ka, toa. So, S-O-H, ka, C-A-H, toa, T-O-A. Okay, SOHCAHTOA helps you remember that. Another memory trick is Oscar had a hold on Arthur. Okay, so whichever way you like to remember that, you can use SOHCAHTOA or you can use Oscar had a hold on Arthur. The only thing with Oscar had a hold on Arthur is you do need to remember that it is sine, cosine, tangent that that's going to go with. Okay, all right. Along with this, as we're calculating this, these calculations right here are fairly simple. There's really not a big problem with those. But as we move on with this, you're going to want to use your scientific calculator in order to figure these out, because we're going to look not just at figuring out that where we're given those sides, but perhaps if we have the cosine of an angle, but we don't know what the sides are, we would use a calculator to figure that out. So say if I know that the cosine of, or if I'm wanting, I'm wanting to calculate what is the cosine of 39.2. Okay, so I have a 39.2 degree angle and I want to find out what is the cosine of that. Okay. What you need to do is figure out what kind of calculator you have and take that calculator and go find a YouTube video that goes with that in order to figure out how to do it. On your book in lesson 43, there are some instructions, but again, that's for the calculator that they're using and you might be using a different one. In the book, what it tells you to do is to enter 39.2, hit the cosine button, and then you'll get your answer. Well, that works for me on the the calculator that's on my phone, I can hit the 39.2 and then hit cosine. So on my phone, I would enter 39.2, and then I would hit the button cosine, and then I would hit the equal sign, and it would give me 0.7749444488. Okay, but I have a TI 84. On that calculator, I have to actually hit the cosine button first. Then I key in 39.2. Then I hit the enter button. Okay, and then it gives me the answer. So you need to work with your calculator, and really the best way to do that is just look for a YouTube video. Just Google it, and you'll find someone who will show you how to do that on the calculator that you have. You can use the Texas Instruments calculator. You can use the Casio calculator. It doesn't matter the type that you get. As you do that, you do want to make sure that whatever you get is a calculator that you will be allowed to use when you take the SAT. Some calculators can be used, other ones cannot. So do make sure that you get the right calculator so that you can take it into the test. I want to go on down and look at the example 43.1 there in the book. Okay, there in that example, they show you those three different triangles. Okay, and what they're doing, they're giving you the three triangles and they're telling you find the sine, the cosine, the tangent. So the first triangle, they want you to find the sine. Okay, so with that first triangle, you see they have this, which if I drawn it better, that's what we need right there, not this one over here. Okay, so here is a right triangle. This, by the way, only works with right triangles. I have this angle over here, A, and that's what they're wanting you to solve for. They're giving you the three different sides. Okay. All right, and they're telling you to find the sine. So they're asking you, what is the sine? Okay, well, we know that the sine, or Oscar had, is the opposite over the hypotenuse. Okay, so if I look at that, my opposite side is the 4 over there, and my hypotenuse is the 7. Okay, so this is going to be the sine equals 4 divided by 7. So the sine of angle A is going to be 0.57. Okay, they then go through and have you take with the next triangle, they want you to find the cosine of B. So they've given you this triangle here. All right, your B is over here. This is a 90-degree angle, and we have the 8.6. We have the 5, we have the 7, okay? With the cosine, okay, we remember we had the ca, that's the CAH. So this is going to be adjacent over hypotenuse. All right, so with this 7 is the one that's adjacent, okay, and the 8.6 is my hypotenuse. Okay, so 7 divided by 8.6. Remember with this, the hypotenuse is the one that's across from your 90-degree angle. Okay, the opposite is the one that's across from the angle that you're considering, and the adjacent is the one that's left over. And the adjacent is going to be one of the two lines that actually make up the angle you're talking about. Okay, so with this right here, do this calculation, you get 0.81. All right, and then that final triangle that they've given you there. All right, we've got this. Here I have my C over here. That's the angle. I'm trying to find out what is we're actually going to do the tangent on this one. Okay, I remember we had the TOA, or Oscar had a hold on Arthur. So here's the on Arthur part. Okay, my opposite side is 6. My adjacent side is 8, so this is going to equal 0.75. Okay, with the things that they've had you do right there so far, you haven't really needed to worry about using your specifically scientific calculator. You could just do those calculations on a normal calculator. And the next thing that we are going to go to, oh, let me cover one more thing real quick. If you were looking at something where you needed to, sorry, I was sitting and thinking about what I'm trying to say. All right, sometimes you might have the fact that they're looking to have you take a cosine or a tangent and multiply by another number. So they would look at the idea of 4 cosine 57.2. Put my decimal point in the wrong spot. Okay, ignore that. 57.2. All right, so if they're looking for that, that's really just the idea that I'm going to find the cosine of 57.2 and multiply it by 4. So you'll need to see how your calculator wants to do that. Okay, so to find this value of 4 cosine 57.2, you can enter the 4 first or enter the cosine of 57.2 first, whichever way. They show in the book them doing the 4 times 57.2 and then hitting the cosine. Remember, the calculator that they're doing, you wind up doing this 57.2 and then you do the cosine after. Okay, with my calculator, I would need to hit the cosine. I would hit the 57.2 and then I would hit enter, which is going to give me the cosine of 57.2. I would then hit times and 4. Okay, mine would go the opposite direction of the calculator they have in the book. So make sure you just see how that is going. You do want to make sure that you actually are finding the cosine of 57.2 and then multiplying that by 4. You want to make sure that you're not taking 4 and multiplying it by 57.2, getting an answer, and then finding the cosine of that answer. You want to make sure that that's not what you have going on, okay, because that would not be the same thing. Okay. Last thing in this chapter is looking at the inverse functions. Okay, so this is going to be, if I have that this, I know that the sine of, say I know that the sine of 30, of a 30-degree angle is 0.50. Okay, so what we're looking at here, the inverse sine of a number is the angle whose sine is the number. All right, so they've said that to us, and we know that this right here. So what I'm saying here is, if I happen to know that the sine of some angle is 0.50, and I'm wanting to figure out what is that angle. I know the sine. I know that the sine equals 0.50. So what's the angle? All right, so that's where we're going to use our inverse function on our calculator. Okay, so for me, the way that this is going to work, by the way, when you look at the inverse function on your calculator, it's often going to look like, say, sine to the -1. All right, cosine to the -1, and tangent to the -1. That's what you're looking for. So for me on my calculator, I have the sine button, and then right up above it, it says this right here. It says the sine to the -1, and for me, that's in a different color. So in order for me to get the inverse function, I actually have to hit a button called second, and then I hit the sine button, and that gives me the inverse. So for me, what I'm going to do, if I know that the sine equals 0.5, excuse me. If I've got the sine equals 0.5 and I want to find out what the angle is, I'm going to wind up hitting second sine 0.5 and then enter. All right, and when I hit those, I get, actually, 29.9 something, something, something. Okay, and so then I'm able to round it off and find that that's a 30-degree angle. Okay, so that's how we're going to find those inverse. All right, if they've given you that the tangent equals 0.5777, you would hit, for me, it's second. For someone else, it might be, you might actually have a button called inverse, like I said, that, or a button called second. There's going to be something else that you need to hit to get the words that are written above your keys. Okay, so if I'm looking at this right here, I have this tangent. I would hit invert or the second. I hit the tangent key. Okay, I'm going to wind up entering in this 0.5777, and then I can hit enter. All right, and when I do that, it's going to give me 30. It's actually going to be close to it. I'm going to have to round it up. Okay, so that's how those inverse tangents are going to be used, inverse tangent, inverse sine. So that is if you have the actual sine, but you're trying to figure out what is the angle that goes with. Okay, all right, hope that helps, guys.